Hi, my name is Raghavendran and my student ID is 21000253. So today I'll be talking about the CET1 schematic diagram involved in our geothermal power plant in IDP project. So first of all, the production well supplies the superheated steam into the flash separator where vapor and liquid is separated. It is then pumped through the turbine where electricity is generated and it's sent to the generator. It is then recycled back into the condenser where air acts as a cooling medium to return the working fluid to its original state before re-injection into the re-injection well, where it goes through the geothermal well to receive energy back once again. The air that comes out of the condenser is used to cool the ice blocks in the surrounding so that it could be sent into the distillation column for fresh water production.
Hello, my name is Funjaha and I am going to explain the compressor and turbine parts. So, starting with the compressor part, we know that the energy change of a system is equal to the rate of energy going in subtracted by the rate of energy going out, or E system is equal to the difference between E in and E out. As you can see here, W in plus MH1 is equal to Q out plus MH2 plus MGZ, whereas MGZ is the potential energy. Since H1 and H2 are equal and have the same condition sets for the turbine process, doing the substitution values in Wn equal to M in brackets H1 minus H2 plus mgz, the H value will be 0 and the mass flow rate multiplied by the H value will be 0. Therefore, Wn is equal to mgz. And then we substitute the values for mgz. Wn will be equal to 250 kilograms per second multiplied by 9.81 meter per second and lastly multiplied by 0.8 kilometers, which is equal to 1962 kilowatts or 1.962 megawatts. Moving on to the turbine part, the mass flow rate multiplied by open bracket H set plus V1 squared divided by 2 plus GZ1 close bracket is equal to W out plus mass flow rate multiplied by open bracket H3 plus V2 squared divided by 2 plus GZ2 close bracket. And then we also know that the change in kinetic energy is equal to the change in potential energy, which is equal to 0. So MH3 is equal to MH1 minus W out. So after we substitute the value in, so H3 is equal to 62.5 kilograms per second multiplied by 3,396.76 kilojoules per kilogram minus 40,000 kilowatts, and then H3 is equal to 2,756.76 kilojoules per kilogram. So from table A5 at pressure 650 kilopascals and temperature 161.98 degrees Celsius, we can see that HF is less than H3 and H3 is less than Hg. So 684.08 kilojoules per kilogram is less than 2,756.76 kilojoules per kilogram, which is less than 2,759.6 kilojoules per kilogram, which indicates that it is a saturated liquid vapor mixture. That is all for the compressor and turbine part.
Hi, my name is Emmeline Sophia and I'm going to explain about the condenser. This is how our condenser looks like. When entire heat exchanger is control volume Q equals to 0, then E in minus E out equals to delta E system. MWF times H3 minus H4 kilojoules per kg equals to M air H6 minus 283.136 kilojoules per kg. Insert all the values. H6 equals to 1,319.476 kilojoules per kg. From table A17, we use the interpolation method and then we get X equals to 1,250.76 Kelvin. TC out equals to 977.76 Celsius.
Hello, my name is Megat Muhammad Haziq bin Muhammad Faiz and my ID number is 2000394. So this is the pump that re-injects the superheated steam back into the injection well, and the basic energy balance equation is used here as the same as the others, where the work input is calculated and it is found that 41.188 megawatts of power is needed for the pump.
In the geothermal well, in order to complete the power production cycle, the geothermal steam will act as the working fluid must be returned back to its initial state before being pumped to the turbine once again. Therefore, the geothermal steam receives 635 megawatt of heat from the geothermal well from the energy balance equation as stated as above to return to its initial state. Heat gained by the geothermal steam is defined as Qin. Lastly, there is the actual power produced and the BWR, which is the back work ratio. So the actual power produced is obtained by substituting power consumed by compressor and power consumed by pump from the power generator in turbine. So therefore we get 86.85 megawatts of power. The backward ratio, which is in alternately the WCP, which is the work consumed by the pump and the compressor over the work generated by the turbine, and we get a total amount of 0.332 ratio. Thank you so much.